All right, in this lesson, question 2 of 4A labor market equilibrium, we're going to look at, we're going to do a deep dive on labor demand. We're going to get a feel for how we observe empirically the employer side of the labor market. Now, in this problem, we have this company called Osgood French Fry Company. They produce gourmet French fries. And like a bunch of other firms, it hires employees from a local labor market. Research from an industrial trade union estimates that 655 workers are employed in this labor market at an hourly wage of $15.89 per hour. These workers are native born and educated in good public schools. A natural disaster in a nearby country triggers a mass migration into the labor market, which pushes the hourly wage down to $9.99. At the lower wage firms with higher cost structures than Osgood French Fry enter the labor market to hire workers. The entrants and the incumbents, the incumbent being Osgood French Fry and the other low-cost firms, hire 280 more full-time workers. The research from the industrial trade union indicates that these new jobs were filled by migrant workers who did not have any formal education. We're going to complete the following table and then do the analysis, right? So at 1589, right? At 1589, there were 655 workers in this labor market, right? When that migration happens, the wage falls to $9.99, right? And that causes 280 more people, 280 more full-time workers to be hired, right? So there are 655 already in this labor market. 250 more are added, right? So we have to add the two together, right? So I'll do it right here. 655 plus the 280, right? 655 plus the 280. I got to make this 655. I got to make this 1589. I got to make that 9.99. This is the hourly wage. I'll just call it W. And this is the employment level. I'll just call it E, right? I'll call this W for hourly wage. W and E, right? So this is 935, right? We're adding that 280 to the 655, right? Now in Excel, we're going to highlight these 6 cells. And we're going to build a scatter plot like we did in the previous question, the previous lesson, right? So if we highlight this, and then we click Insert, Recommended Charts, then we go to All Charts, we can go to Scatter, and again, we have 2 points, so we don't want to pick this chart. We want to pick this chart over here on the right, right? It's got 2 points. Okay, so these 2 points comprise an estimated labor demand, right? Now, in the real world, we're going to have a lot more points, right? But these 2 points provide us with a labor demand curve that we can estimate. And the way we can do it with, Excel scatter plot tool is we can right-click on this point. We can add a trend line. Oh, one real quick thing here. I got these backwards, right? So one thing we can do to fix that is we can drag these around so that W is the thing that we're predicting and our independent variable is employment level, right? So we can change this to here to labor demand, right? Probably want to call it estimated labor demand, right? Estimated labor demand. Okay, so we want the wage rate on the vertical axis because the wage rate is on the left side of this equation. And we want the employment level on the horizontal axis, right? In the first quadrant, that means E is on the right side, right? E is on the right side. And then the wage rate is on the left side when we're in this first quadrant right here, right? So I'm going to get rid of the grid lines. Then I'm going to right click on a data point. I'm going to add a trend line. I'm going to make sure its line is chosen, linear. And then I'm going to display the R square and the equation on the chart, right? And then what I'm going to do is I'm going to add a row here. I'm going to call this wage rate. I'll do this. I'm going to copy this formula here. The equal sign and the right side of this equation, right? I have the intercept, which is 29.692, and I have the slope, which is a negative 0.0211, right? I'm going to copy that right here. Okay. And then I'm going to change this X to times. And I'm going to click and I'm going to click on cell B4, right? Now, when the employment level is 0, right? When the employment level is 0, the firms are willing to pay $29.69, right? So what I'm going to do is I'm going to extend this line. I got to delete that. Hang on a second. I want to extend this line to include this 0. And I'm also going to extend it a little further to include values along the labor demand curve, kind of like we did yesterday, right? So this is the intercept, right? When the employment level is 0, firms are willing to pay $29.69 per hour, right? And then this is the point that corresponds to a wage rate of $15.89. At $15.89, firms are hiring 655 employees. At $9.99, employers are hiring 935 employees, right? So I'll right click and then I'll add a trend line. And the trend line will be exactly what it was before, right? Okay, so the equation is exactly the same as it was, right? Adding this point doesn't change the equation because all three of these points are on this line, right? Okay, so the slope is the thing that's to the left of X, right? I don't need the negative sign because that's negative right there, right? So I'm just going to type 0.0211. Again, I don't need the negative because it's negative there, right? And then I got 29.692, right? Now we're going to use this estimated labor demand equation to answer the questions that follow, right? And we're going to do that right here. So this right here is the intercept. I'll make that blue. And then this is the point we're going to be calculating here, right? I'm going to make this red. We're going to calculate points along the demand curve, right? I'm going to pull this down and then make it red, right? Okay. Now, the maximum wage firms with the highest willingness to pay is what? Well, to calculate that, we have to ask the question, how much firms are willing to pay the first worker that is hired? How much are they willing to pay that person, right? So we replace E, the employment level, right? Replace E, the employment level, with 1, right? So we're essentially plugging 1 into our labor demand equation here, right? When we plug 1 into there, what we're saying is firms are willing to pay up to $29.67 per hour to hire that first worker, right? So if these firms haven't hired anybody yet, how do they hire these workers? Well, they post a job announcement, right? They have this job opening. they have these job openings, right? Maybe they just open a new factory, right? So imagine the situation where the factory just comes to the town, comes to this labor market, opens up, and now it needs to staff it, right? So how does it staff this factory? Well, it announces that it's hiring a bunch of people to work in this factory or factories, right? So people apply. And what do people do? They fill out applications. And those applications include any specialized skills that they might have, any education that might be applicable, right? Any training, any work experience. They include letters of recommendation or contact information for people who will recommend them for the position, right? So what firms do is they accept all these applications and then they order them from the most highly priced employee applicant to the lowest. And the employee that is valued the most is this employee, right? This person is number one in line. This last employee is in my case, the 935th, right? The 935th, right? Valued employee or applicant, right? And they're placed in a queue. So you can think of these little dots as all the individual applications, right? And the height of these dots are the value that the firm places on each one of these employees, right? Okay, so that's how you can think of the labor demand curve. It puts people in a line with the highest value to the company, the most productive, right? On the left, and they're willing to pay that very first employee a lot of money, all the way down to the least valued of the applicants, right? Maybe the person with the least amount of training, the least amount of experience in related occupations, and maybe the least trusted recommenders for the position, right? So you put them in a queue, highest value on the left to lowest value on the right, in terms of what you think their productivity is going to be, right? Okay, so the firm is willing to pay this first employee $29.67. Now, because labor demand is constrained by the supply, I'm going to draw a labor supply curve in here. The labor supply curve might be right here, right? Initially. So this is before, the catastrophic weather event that caused all that migration, right? This is the before, right? So we have this labor supply here, and it might be steeper, it might be flatter, more elastic, less elastic. We don't know. We just know that it intersects this point here, right? We know it intersects this point. Okay. How steep it is, we don't know, right? Okay, so with this labor supply curve, the dotted line connecting these 3 points intersecting this labor supply curve at the point in the middle, right? At a wage of $15.89, 655 people are employed, right? At this wage of $15.89. So although the firm is willing to pay this first employee $29.67 for their services, right? They only have to pay the market wage, and the market wage is $15.89, right? Oops, $15.89. Now the employer wins, right? Because they're willing to pay $29.67, but they only have to pay $15.89. So they win this transaction, right? So that difference is called employer surplus, right? And what we'll do is we'll calculate the employer surplus down here. I'll call it firm surplus or producer surplus, right? Firm surplus. And that's going to be the market wage, right? The market wage subtracted from the wage they'd be willing to pay that particular employee, right? And that firm surplus is $13.78, right? Okay, so this is the wage they're going to pay that first employee. And this is the surplus, right? The extra, right? The firm's surplus of that employee, of hiring that employee is 1378, right? Okay, the max wage the firm will, with the third highest willingness to pay, or the second highest willingness to pay, uh, um, is equal to what? Well, now we got to change this to the second employee, right? What are you willing to pay that second employee? That second employee has the second best set of credentials, right? And experience and references, the second best, judged to be the second best. Well, you're willing to pay that person $29.65, right? And they only have to pay the market wage, right? The market wage of $15.89. So although they're willing to pay $29.65 to the second worker, they're only going to pay $15.89, right? And the employer surplus is $13.76. It fell a little bit, right? And it falls because this is the second most productive worker in your judgment, right? So you're not going to pay them as much as the one that you're not willing to pay them as much as the one that you judge to be the best, right? Okay. Now, what about the third highest willingness to pay? Okay, so the maximum wage to firm with the third highest willingness to pay is what? Well, now we got to look at that third employee, right? The third employee, in terms of productivity, right? Established record of training and education, the quality of the recommendations from his or her references. This person has been judged to be the third most productive, right? So the firms are willing to pay this person $29.63, right? And again, they only have to pay the market wage of $15.89, right? So the firms win in this transaction here, right? The consumer surplus is dipped 13.74, right? Because that willingness to pay has drifted a little bit, right? This is the third. This person is judged to be the third most productive. So that valuation on this third employee is lower than the second and the first, right? Resulting in a lower, slightly lower employer surplus. Now, the maximum wage the marginal firm is willing to pay the marginal worker is what? Well, the marginal firm and the marginal worker exchange a wage for labor services at the equilibrium, right? So the marginal firm is the firm that hires this last worker, and the last worker hired is the marginal worker, right? And so this marginal worker is paid the market wage, right, of $15.89. So that marginal worker is worth, and the marginal worker in this case is the 655th, right? The 655th worker is the last worker hired, right? Why is that worker the last worker hired? Because if you plug 655 into the labor demand equation, you get the maximum amount of money per hour that firms are willing to pay this last worker hired, right? And that is $15.89. Okay. The wage that this marginal firm pays the marginal worker is the market wage of $15.89. So the firm surplus here is zero. Firm surplus is zero, right? Because this last worker hired is estimated to be worth, that person's labor is estimated to be worth $15.89, just $15.89, which is equal to the market wage, right? And that's why that person is the last. The marginal worker is the last worker hired, right? Now we got to calculate the total surplus, right, at $15.89. Okay. Now to calculate the total surplus and total employer surplus, right? Employer surplus. Let me draw another line in here. Let me draw in a triangle. Drawing a triangle here real quick. You want to calculate this area here, right? So we don't need an outline. We're going to make it yellow, and we're going to make it transparent. Okay, we're going to calculate the area of this triangle, correct? And so this bottom edge of the triangle is at the market wage of 1589, right? It's at 1589. You can see it right there, right? The height of this triangle, the top edge of the triangle, its highest point is the intercept, 29.692, right? And the width of this triangle is the difference between the number of employees hired, which is 655, right, minus 0. So the length of this edge is 655. The height of this edge is the difference between the intercept, 29.692, and the market wage of 1589, right? So we need to calculate the area of the triangle, right? Now, one way to think of this is we as the sum of each one of these consumer or employer surpluses, right? We could record this value, right? We could record that value there. I'm going to show you a little trick. Let me try this out real quick. Hang on, I'm going to set it up. All right, so I've squeezed the diagram here, and I added a name here called firm surplus, and this is going to be employment level, right? And I'm just going to drag this down to 655, right? The cool thing about Excel is I can make a sequence of numbers by grabbing two of them and then dragging them down. So I'm going to pull this down to when that thing said 655 there. Whoop, a little too much. There we go. Right there. Okay. And then I'm going to insert. I'm going to do equals. I'm going to calculate the firm surplus here, right? And I'm going to highlight everything below, right? Okay, so this is going to be employment level. I'm going to go to data. Let me widen this up a little bit. What if analysis? I'm going to do a data table. This is really cool, right? I'm going to show you a really cool Excel trick here. Data table. And then the input cell, we have a column here, and these are these are employment levels. And we're going to change it from one employee to the second employee, to the third employee, to the fourth employee hired, et cetera, et cetera, et cetera. So, and these are in a column. What I'm going to click on this button here, then I'm going to click on the 1, right? So what I'm going to do is this data table is going to alter the 1 from being 1 to 2 to 3 to 4 to 5. Then it's going to calculate the firm surpluses of each of these workers hired, right? I'll click OK, and I'll hit OK. Okay, so notice it starts out at 1378 right here, right? Let me do this. I'm going to reduce it to 2 decimal places, right? So I have the firm surplus of the first employee, the second employee, the third employee, the fourth employee, the fifth employee, all the way down. Now, due to round off errors, the final firm surplus for hiring the marginal worker, it ends up being negative. And it's just because of round off error, right? But you can see that the firm surplus is going to zero, right? So what I'm going to do is I'm not going to include this as part of the calculation. I'm going to sum all the firm surpluses that are positive. So this is one way to calculate firm surplus, right? Down here at the bottom of Excel, you can see the sum is $4,500, right? So I can calculate the firm surplus, the total firm surplus, or the total employer surplus. I can calculate that total employer surplus by adding up each one of these individual surpluses for these individual employees hired, right? Or I can calculate the area of the triangle, or right, the area of the triangle. So the firm surplus could be the sum, right? The sum of these 650, we'll call it 654, since that one is negative. So the firm surplus is 4,500, right? $4,507,020, right? We can do it that way, or we just calculate the area of the triangle, right? And the area of the triangle, total firm surplus, right? The area of the triangle is the height of the triangle, right? The height of the triangle is the 1589, the intercept, 29.69. That's the intercept because we have zero here, right? So this right here, 29.69, is this 29.692 there, right? So we're going to subtract the intercept from this market wage of 1589. That's the height of the triangle. We're going to multiply that by the width of the triangle. And the width of the triangle is the employment level, right? Because we got 0 out here to 655. And then we're going to divide that by 2. Right? And you can see that the area of the triangle, and the sum of the firm surplus for the first employee, the second employee, the third employee, yada, 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 out to the last employee hired, they're about the same, aren't they? They're roughly equal to each other. Now, we generally just use the area of the triangle, right? We just generally use the area of the triangle. But I thought I'd show you this little trick that you can use, right? A data table. It's kind of slick, right? If we use this value in our answer, we're going to get it wrong because the algorithm is using the area of the triangle for this calculation here. So we're going to use this one to 2 decimal places. Right? So the total firm surplus or employer surplus, the firm here is an employer, right? So again, we can get this total employer surplus by adding up these individual firm surpluses for each of the 655 employees hired, right? Which we did in this data table over here. Or we can just calculate the area of the triangle, right? And generally the area of the triangle is the one that's preferred because it's a quick calculation, right? Now, total surplus measures the total benefit that accrues to what, right? Initially, right, before the mass migration occurs, right? Who, by assumption, populates these firms that hire all these workers? Who are the workers, right? Before the migration, right? The workers are educated in good public schools, and they were born in the country. They're native born, and they were educated in good public schools. That's the workers, right? Now, who are the firms? The firms are Osgood French Fry Company and other low-cost firms, right? Those are the firms. After the migration occurs, right, the wage gets pulled down and other firms enter this market, right? The firms that enter this market were previously not in the market. Their cost structure is a little higher, right? So before the migration, higher cost competitors were not in this labor market. Only the low cost firms, which includes Osgood French Fry Company, were in this market hiring these workers, right? So down here, total surplus measures the total benefit that accrues to Osgood French Fry Company and other incumbents, right? Osgood French Fry Company is not the only one in this labor market. The other incumbents and Osgood French Fry Company are the incumbents, and they're also low-cost producers, right? They're low-cost producers. All right. Now, assume the demand line represents a queue of applicants from the most qualified, which we talked about, labor demand's y-intercept, to the least qualified, labor demand's x-intercept. So if we continue this line down here, we'll get to the x-intercept, right? And this is determined by credit and criminal records, Google and social media searches, submitted resumes, job applications, letters of recommendations, and interviews. The marginal worker is whom, right? Who's the marginal worker? Well, they're going to be the native-born workers from good public schools, right? Because the migration hasn't occurred yet, right? The migration hasn't occurred yet. And we assume that native-born workers from good public schools were in this labor market, right? And the marginal firm is going to be Osgood French Fry Company, right? Osgood French Fry Company might be the firm. It's producing a gourmet French fry, right? So it's going to have probably a slightly higher cost structure than the other low cost incumbents, right? So that's why Osgood French Fry Company is the marginal firm here, because it's producing a gourmet French fry, which is more expensive to produce. So it's going to be, of the low cost incumbents, it's probably going to have the highest cost, right? So Osgood French Fry Company is the marginal firm, right? But that all changes when what? That all changes when we have this mass migration, right? Due to this weather event. The weather event pushes down the wage rate because a bunch of people from another country come to the nation, and those people enter the labor market, which is going to pull down the wages, right? Okay. So now we're going to answer the same questions we did above, but with these new workers who have migrated from a country that has suffered a horrible weather event, right? So now what we have to do is we have to change our model here. We're going to subtract the wage firms are willing to pay the first employee, the most productive of the employees, the one that's judged to be the most productive. We're going to subtract from that the new market wage of $9.99, right? 99. Okay, so at this new lower wage, right? At this new lower market wage, right? Firm surplus of hiring that first worker is now 1968, right? It was 2960, or sorry, it was 1378, right? Now it's 1968, right? Because they'd be willing to pay that first worker 2967, right? But only have to pay them, that person, $9.99, right? Per hour, right? So the firm surplus has increased. So firms are generally, whether they know this or not, they tend to support migration from other nations, because what does it do? It increases their firm surplus, right? So you could think of an open border as a pro-business policy because it increases the firm surplus of firms, right? Now, what about that second employee hired? That second employee hired, firms were willing to pay that person $29.65 an hour, but now only have to pay the person $9.99. So the firm surplus of the second highest, the person is judged to be the second most productive worker in the labor market, their firm surplus is now 1966. It was 1376, right? And that's just because the wage firms have to pay is now lower, right? Due to the migration. And then you have the third worker, the person judged to be the third most productive. Firms are still willing to pay that person $29.63, but only have to pay the person $9.99, right? And so that increases that third worker's firm surplus that accrues to the firm, right? Now, what about the marginal worker? The marginal worker is no longer number 655, right? The marginal worker is now 935, right? The 935th person hired. That's the new marginal worker. And that new marginal worker is a migrant who did not receive an education in a country that suffered a massive weather event, right? That caused the migration, right? So the new marginal worker is a migrant with a poor education, right? A bad education. And that person's, that 935th person's surplus to the firm is zero because they're judged to be the 935th most productive employee, right? Based on a bunch of different factors, including information in a resume and recommendations or lack of recommendations, training and whatnot, right? Well, the firm's only willing to roll the die and hire that person because they value that person's productivity at $9.99, which is the market wage, right? So that marginal employee, the marginal worker, is going to get paid, is worth to the marginal firm only $9.99 per hour. And the wage that the marginal firm pays the marginal worker is the $9.99. It's the market wage. And the employer surplus is zero, right? So we know who the marginal worker is. Who's the marginal firm now? Remember, before the migration, Osgood French Fry Company, a large low-cost firm that produces gourmet French fries, it was previously the marginal firm, right? But when that labor migration lowers the hourly wage rate in this labor market, it draws firms in this labor market, firms that now hire from this labor market, because now at $9.99, their margins, they're going to have sufficient margins to operate with labor hired from this labor market, right? So the new marginal firm is going to be a high cost producer, right? Maybe a very niche French fry company, right? With a very interesting take on French fries with weird flavors and limited runs, right? They can now enter this labor market and hire labor from it at $9.99, right? So that's the new marginal firm, right? That's the new marginal firm. Okay, so total surplus measures the total benefit that accrues to, now there's more than just Osgood French Fry and the other incumbents, right? And the total employer surplus is not just the surplus to the new entrant, it's to all the firms, right, in this labor market. Okay. At $9.99 per hour, the marginal worker is, like we said, a migrant worker with no education, right? They were drawn to the nation, drawn into this labor market because of this cataclysmic, horrendous weather event that eliminated employers and homes and whatnot in their home country. So they come here, right? And enter this labor market and it pulls down the wage. So they're the new marginal worker. And the marginal firm, like we mentioned, is not an incumbent, right? It's not Osgood French Fry Company. Osgood French Fry Company has the highest production costs of the incumbent firms, who are all low-cost firms, right? So it's not the incumbent firms, right? It's not the incumbent firms excluding Osgood French Fry Company. It's not all the firms. It's not Osgood French Fry Company. It's the new entrant, right? These new entrants have higher cost structures than Osgood. They have higher cost structures than the incumbent firms other than Osgood, right? They used to have higher cost structures. If they didn't have higher cost structures, they would have been in the labor market prior to the migration, right? Okay, now we can calculate the new total surplus, right? So we have this triangle here, right? We have this triangle. And what we got to do is we're gonna add to it, right? And we got to, I want to change the color of it to, I don't know, a bright blue, I guess, bright light blue. And now we also have a rectangle, right? We have this new rectangle. Yeah, can't really see that, can we? Okay. Let me change it to like that. Okay. So if the native-born workers aren't displaced by these migrant workers, right? If they're not displaced by these migrant workers, then the workers that populate the labor demand curve from here to here, they're native-born workers with a good public education. The workers from this point to this point are foreign-born workers with a bad education, right? Now, it could be the case that because this wage has been pulled down to $9.99, right, that the native-born workers exit this labor market because $9.99 is below the reservation wage, right? That could be the case, right? We'll talk about that in a second, right? So we have the yellow area, the pink rectangle, and this blue triangle here. All three of those together represent the total employer or firm surplus that accrues to the firms, right? The surplus that accrues to the firms. It represents their gains in this voluntary exchange, their gains to trade, right? Now let's calculate the elasticity, right? I'm going to calculate the elasticity right here. Let me insert. Yeah, hang on a second. I'll just cut and paste over here. Maybe I'll just delete it. There we go. All right. So I'm going to calculate the elasticity. At points along the labor demand curve and then the wage bill. Okay. Okay, so to calculate the elasticity, we need 1 divided by the slope, right? So the change in the change in the wage rate divided by the change that's weird. The change in the wage rate divided by the change in employment. That right there is the D stands for change, right? Difference. So the difference in wages over the difference in employment. That is equal to negative 0.211, right? That's the change. Now the elasticity wants that reversed, right? That flipped. It wants the inverse of that. Elasticity wants the change in employment over the change in wage, right? The change in employment is the change in a quantity. The change in wages is the change in price. So we have to flip that, right? So what we want to do to calculate the elasticity is we need the change in employment over the change in the price, right? The change in quantity divided by the change in price. So we're going to flip that, right? We're going to divide it into 1, right? So that's the change in employment over the change in wage, right? So if wages go up by $1 per hour, then employment's going to fall by 47, right? That's what that means. Okay. And that's what we're talking about here, right? When we're calculating elasticity along labor demand, we want the inverse of the slope, right? Then we get, this is converted to a percent change in employment divided by a percent change in wages if we multiply this by the wage employment ratio at a given point. So up here on the elasticity, I'll put it in parentheses slope here, right? In parentheses, I'll put 1 divided by slope. Okay. So the elasticity is going to be equal to 1 divided by the equation slope, right? Times the wage at the point, right, on the demand curve, divided by the employment level, right, at that point. So we have an elasticity initially of equaling negative 1.15, right? Initially equal to 1.15. Now, if I drag it down, I have a problem, right? I have a problem because I need to freeze this row here, right? So I'm going to multiply the 1 over the slope of my equation, right? I'm going to divide that. I'm going to multiply that by the wage employment level ratio, right? So I got this value times the wage rate divided by the employment level at the other point, right? Okay. So my elasticity in absolute value was bigger than 1 at the higher wage. My elasticity in absolute value is between 0 and 1 at the lower wage, right? So this implies labor demand is elastic at this wage, and this implies labor demand is inelastic at this wage. And remember what inelasticity means. Inelasticity means you're insensitive to a price change, right? And what that means here is when wages are really, really low, right? If wages go down a little bit, right? If wages go down a little bit, like, for example, the way you interpret this is if wages go down by 1%, employment goes down by, well, we'll say if wages increase by 1%, I think it might be more intuitive. If wages increase by 1%, then the number of people we hire goes down by a larger percent, 1.15%. Now, when wages are lower and you get a 1% increase in the wage, the employment level will go down by a smaller percentage, right? So your firms become insensitive to a wage increase, if they have to pay higher wages, they become insensitive to those wage increases. If wages are relatively low, right? If they're really low, you're going to be very insensitive to wage increases, right? So if you're a member of a labor union, and the elasticity is, say, -5, right? Should you go on strike? Probably not, because those firms are very sensitive to a price increase, right? To wage increase. So if the elasticity were like, say, -5, what that means is, if the union can negotiate a 1% increase in your wage, firms are going to agree to that only if they get a 5% reduction in the workforce, right? And you might be one of the lucky ones, unlucky ones, that lose their job as a result of the union demand, right? Now, if instead the elasticity of labor demand in a unionized field is elastic or inelastic, like it is here, if wages are like low and the union demands, 1% increase in the wage rate, firms are going to respond with a very small request that the union reduce its membership by 0.5%, right? So you want to know what your elasticity is if you're a member of a union and you're voting on whether to go on strike to get a wage increase, right? It could result in a huge decline in employment level, right? So our elasticity is initially negative 1.15, and then it ends up being negative 0.51. The wage bill is just simply the wage times the employment level. You can think of the wage bill in terms of the employees as their collective revenue. If the employees were like a service provider, right? If the employees were organized like a union, right? You can think of the employees as a business who is selling their services to a firm, right? And this you can think of as their revenue, right? On the employer side, this is an expense, right? A wage bill, right? So to the employees, if they're working collectively, if they're colluding to work together, you can think of it as them providing a service to somebody wanting to purchase their services, right? For them, this would be their firm revenue, right? If these employees were, in fact, a firm selling services. And we see this a lot with contractors, right? A lot of firms are not hiring janitors anymore. They hire firms to clean their restaurants, right? They'll hire a janitorial service, right? So to me, a group of workers is really no different than the firm they're working for. Everybody is supplying a service, right? The workers together are providing services to the firms they work for, right? It doesn't matter if they're officially a collective and incorporated as a service providing firm, right? They're selling their services to the firm, and the firm is buying their services, right? Which is not unlike the firm. The firm uses those services to make goods that it sells to consumers, right? So to the firm, this is an expense, right? This is their total labor expenses, also known as a wage bill, right? So the wage bill at 1589 was 10,407, right? And 95 cents. Their wage bill dropped. They cut their expenses to $9,340.65. Right. Okay. The hourly wage bill of all firms in the labor market reaches a maximum when the elasticity is -1. So if I could show you, if we calculated the wage bills for each of these wages along this labor demand curve, right? We would draw a parabola that rises and then falls, right? And that wage bill would reach a maximum. It'd reach a maximum up here where the elasticity is -1. Okay. Okay, so now what we want to do is we're going to log employment levels and log wage levels, re-estimate our labor demand curve, and the slope of the log-log model that results, that slope is interpreted as an elasticity, right? So what we're going to do here is we're going to do log E, right? We're going to do log E. And then we're going to do, whoops. We're going to do log E, and then we're going to do log wage, right? We're going to estimate the elasticity using, simple regression, a scatter plot with a trend line, a best fit line, right? We're going to take the natural log of the employment level, and then we're going to take the natural log of the wage, right? Whoops. This one is over there, right? Natural log of the wage. And we're going to drag these two down to get, all four of them, right? Simultaneously. So we have the natural log of that 655. We got the natural log of the 935. We got the natural log of that first wage, 1589. And we got the natural log of that second wage, 999, right? And then we're going to re-estimate this equation. I'm going to highlight all six boxes here. I'm going to click on insert and then recommended charts, all charts. Go to scatter plot and then pick the one with the 2 points, right? Then I'm going to right click. I'm going to add a trend line. I'm going to make sure linear is picked and then display equation on chart, right? I'll blow it up so we can see it. I'll blow up the font here. The 14. And you can see that the slope coefficient of our variable x here, our slope coefficient is -1.3, right? Which is near our elasticity calculations here, right? So let's just fill in this information. Natural log E when the wage is 1589. Make sure I get the right wage here. So wage is 1589. Natural log E is 6.48. The natural log of the employment level. The natural log of the wage is 2.77, right? And then when the wage, after the migration happens, we have more workers in this labor market, 935. The natural log of 935 is 684. And the natural log of the wage rate, 999, is 2.30, right? Okay, yeah, there's an error in the code here. So what I did is this value here is actually the natural log of the wage rates. And these values here are the natural log of the employment levels. So I changed the headers over here, right? And I was going to flip these out, plot them out. So this should be the natural log of 1589. This one needs to be the natural log of $9.99 per hour. And this needs to be the log of that employment level. And this one's the log of that employment level. So I just got to flip them around. So this one here is 2.77. This one is 2.30. And the natural log of E is 6.48. And the natural log of 935 is 684. Okay. Let's just make sure this equation is correct here, or this graph is correct. Okay, so we want natural log W on the x-axis, right? We want natural log W on the x-axis, and we want natural log E on the vertical axis. We got this flipped around, right? We got to flip it around here. So what I need to do is I need to delete this, and we're gonna flip these as well, right? Okay, so now we got the natural log of wages on the x-axis, and we have the natural log of E on the vertical axis. And we know that because these values are generally bigger than these values, right? And then we can insert our trend line, right? We can insert a trend line that is linear, and then we want to display the equation on the graph. And then increase the font for, I don't know, 14. Okay, I think this makes more sense. So this right here is the natural log. X is the natural log of W, right? X is the natural log of W, right? Right there, see? And then Y is the natural log of E, the employment level, right? And I think that makes more sense numerically. Because the elasticity, this coefficient here, negative 0.7669, is between these two values, right? It's between negative 0.15 and negative 0.51. And that's what we need, right? We need this elasticity to be between these two values. Otherwise, this doesn't make any sense, right? So we estimate the elasticity between this point and that point. We estimate the elasticity. I guess you could think of it as the average elasticity between this point and that point at negative 0.7669, right? The elasticity at this point is a negative 1.15. The elasticity at this point here is negative 0.51. You know, midpoint wise, the elasticity is approximately a negative 0.8, right? Somewhere in the middle, it's a negative 0.8. So that makes better sense. Okay, so I'm just going to fill in the equation. The intercept is the second number here, 8.6056. And the intercept, the slope coefficient of natural log W is negative, which is already there, right? That's a negative. 0.7669, right? That's the slope. And that slope is interpreted as like the midpoint elasticity, right? I guess it wants two decimal places because it says set decimal places to 2. So I'm going to change that 669 to 7. And I'll change this to 8.61, right? There we go. So we get an elasticity of negative 0.77, right? The slope of this equation is interpreted as the elasticity of labor demand. It equals a negative 0.77. It implies that a 1% increase in the wage paid in this labor market will lead to a 0.77% decrease in the employment level. Okay.